Hello and welcome back to Critidas Math. In this video, we're going to be looking at word problems that follow a linear relationship. So in these types of questions, you have to do a few things. The main goal that you have is to find the rule that represents the situation, because that's what you're going to use to actually solve the problem. So find the rule that represents the situation. And if you remember, your rule for a linear relationship is in the form of y equals ax plus b, where a should be a number and b should also be a number. A represents your rate of change, the way that things are changing, rate of change. Could have also heard it referred to as slope. Slope is a little bit more obvious when you're looking at a graph on why you would call it slope, because it's the way that the line is sloping, or how steep or how flat it is. Okay, and then for B, my color, B, that is your initial value. So in your word problem, it's the value that you're starting from, and that you might have also heard referred to as a y-intercept. And again, that is more clear when you're looking at a graph on why we call it a y-intercept, because it's the place where the line intersects the y-axis. So both of those words can be used interchangeably. One works better for a certain context than the other. So initial value is what we're going to use when we're referring to the word problem. Rate of change is also what we're going to use when referring to the word problem. So the problem that we're presented with is an amusement park charges an entrance fee plus a certain amount of money for each time you go on a ride. So before we even look at the rest of the problem, we have to think about what's going on here. So you have an amusement park, you have an entrance fee, which is dollars, and you also have an amount of money for each time you go on a ride. So you have a fee per ride, dollar per ride. So you see that the units of these things are kind of different. Entrance fee is going to be dollars. Dollar per ride, that's your fee per ride. That's a rate. And that's what gives it away, that the fee per ride, that's going to be the rate of change. It's the way that your amount of money is changing. So fee per ride, that is your rate of change. And then the entrance fee, well, that's going to be where you're starting from. Because if you go to this amusement park and you don't go on any rides, you still have to pay to get in. So entrance fee is your initial value. Initial value. So you know that this is going to be the B in your rule, and this is going to be the A in your rule. Now we can actually look at what's going on. So if Kathy paid $12.50 to go on 15 rides, and Julie paid $10 to go on 10 rides. So we have some information here. We have dollars and we have rides. So dollars and we have rides. And we have to figure out which one is X and which one is Y. So remember that the X's are the independents and the Y's are the dependents. So that means that Y always depends on X. So if we're going to put in a little table, and we could just take this information out and put it into a table. So I could put in rides and dollars. So rides and dollars. So Kathy paid $12.50 for 15 rides, and $10 for 10 rides. And now we have to ask ourselves which one is X and which one is Y. So which one is independent and which one is dependent? Does the number of rides depend on how much money we're paying, or does how much money we're paying depend on the number of rides? I'm going to encourage you to pause, think about that, maybe rewind and play it again. So the number of rides depending on the amount of money doesn't really make any sense. If you just give them a certain amount of money, you're not going to have magically ridden a certain number of rides. But if you go on a certain number of rides, you owe the amusement park a certain amount of money. That's how it works. So for each ride, you are paying more money. And another way to kind of realize which one is X and which one is Y is to look at this over here. So because your entrance fee is in dollars, that means that dollars is going to be your y-intercept. It's where you're hitting on the y-axis. So it makes sense that your y's are dollars. And then fee per ride, this thing is where you're multiplying the number of rides by. So it makes sense that this here is your X value. So that's another place to look. So that means that rides is X and dollars is Y. So now we have 2 points. And if we have 2 points, we can find the rule. So I'm just going to make a little bit of space here. Okay, so we know that that's our main goal, right? Is to find the rule, because we can't answer the question until we find the rule. So to find the rule, depending on what you're given, it's always different. So here, since we have 2 points, the steps are going to be, first, find your A, which is your slope, or your rate of change. Your second step is going to be find your B. And then your third step is writing the rule, putting all of that together. So to find A, look at your notes. What's your formula for finding A? Your formula is y2 minus y1 over x2 minus x1. So we follow the notes. You can use either of these 2 points as your first point. It's up to you. I'm going to label 15 as my first x and 1250 as my first y, and 10 as my second x and 10 as my second y. It doesn't matter. You're going to get the same result one way or another. So here, my pro tip, put your fraction line in first with your subtractions, just to get into that habit of doing that so that you don't run into any problems if ever you see negatives. And now you're just going to drop your numbers in. So here, y2, that's 10. I'm going to write a 10. y1, that's 1250. I put 1250 there. x2, that's 10. I'm going to put 10 there. And x1 is 15, so I'm going to put 15 here. And now here you subtract. So on the top you do a subtraction. 10 minus 1250, we get negative 250. On the bottom you do another subtraction. 10 minus 15, you get negative 5. And now here, this is a division. So you need to divide the top number by the bottom number. So let me bring in my calculator. So we're doing negative 2.5 divided by negative 5. Your answer is 50 cents. So 0.5. So we interpret this to mean that your rate of change or your fee per ride is 50 cents. This amusement park charges 50 cents per ride. So rate of change, $0.5 per ride. So notice it is a rate. Okay, so now your second step is to find B. In order to find B, you can use the general rule here and either one of these 2 points to work backwards from. So it doesn't matter if you choose to use 15 and 1250 to work backwards from, or 10 and 10 to work backwards from, because both of these happened at the same amusement park. So it doesn't matter. You are essentially working backwards to find what the entrance fee is. And the entrance fee is the same for Kathy and for Julie because they went to the same amusement park. They simply paid different amounts because they went on a different number of rides. But the entrance fee had to be the same for both of them. So that's why it's completely up to you which one you choose to work off of. So we start with y equals ax plus b, and we put in what we're looking for. We put in what we have to find what we're looking for. So remember, what we're looking for is b because that's the entrance fee. Y is going to be a number of dollars. So we can use Julie's numbers because they're a little easier. So $10. So Julie paid $10. Okay. $10. And she paid $10 when she paid 50 cents for 10 rides. And then she also had to pay that entrance fee. So if I actually, let me expand this out a little bit so I can put all of the units in there. So she paid 50 cents per ride for 10 rides. And she also paid some entrance fee. And we are working backwards to figure out what that entrance fee is. So we know the 10. For the 10 rides that she took, that she went on, she paid 50 cents for each of them. So she spent $5 going on rides. But she also paid for that entrance fee. So if I take that $5 away from the total, then I know that the entrance fee was $5. If I had worked backwards from Julie's numbers, or not Julie, Kathy, from Kathy's numbers instead of Julie's numbers, I would have gotten the exact same result because, again, they went to the same amusement park. So I think that maybe at first, writing it out with all of these little symbols and the rate and some words just to help you realize what this is will make it a little bit more clear. But you don't have to do all of this. We simplify it and we streamline it so that it's faster. And all you do is plug in just the numbers. And A represents a rate. And we recognize that this 50 cents is a rate. And 10 represents the number of rides. And we recognize that that's the number of rides. And B is just a simple letter to stand in for all of these words entrance fee so that you don't have to write it every time. So 10, 0.5 times 10 is 5 plus B, and then you might do the circling, minus 5. 5 equals B. So they are the exact same thing, except here you're really thinking about it as a situation and what makes sense. Here we're using the structure or the format of a linear equation to make this faster. So a lot of these problems and situations that you'll see, you can solve kind of thinking about it and just problem solving. But what you'll notice is that when we tell you that they are structured or that they follow a linear relationship, you streamline the entire process by using these algebra methods because it's going to be faster. So now you have your rule. You found your A, you found your B. So you can now solve for any amount, and I'm just going to move this so I have more space to work. You can now solve for any amount of rides, how much you're going to spend at the amusement park for any number of rides, because you now can do step 3, which is write the rule. Writing the rule, you need to fill in the y equals ax plus b. So you're filling in the numbers that you found. So you're filling in your rate, you're putting that in there, and you're also putting your initial value in there. So y is going to equal 0.5 x plus 5. In words, the number of dollars you spend at the park is going to equal $0.5 per ride times the number of rides plus the $5 entrance. So that's what this very simply, in not a lot of words, not a lot of letters, represents this entire situation. So when you have these word problems, that's the goal. The goal is to get to this part. And once you get to this part, you can finally answer the question. So now the question is, how much would Kim pay to go on 20 rides? Use rule to answer question. Okay, so Kim goes on 20 rides. So looking at our rule, and we can look at our English version, we see that number of rides, that's the X value. You can even just look at your table of values and remember that X is also the number of rides. So you can use this version and say, I know X is my number of rides, or you could have written it out in words and say, okay, number of rides goes here. So this problem, the question you're answering is, what is Y when X equals 20? That's the question. So you take your rule. In the place of X, you are putting the 20. And now all you have to do is the math. So you take your calculator, 0.5 times 20 plus 5, $15. And you answer in a sentence. Kim spends $15 for 20 rides. And that is it. So this is a very standard type of question for linear rules. Actually, before we end this off, I should probably just do a quick graph of it so you can see that we did all of this algebraically and we did not need the graph. But if you wanted to use a graph to give yourself a little bit of an idea of what's happening, you could do that just to kind of anticipate what your results will be. So those, where did my table go? I put it out down here and drag that up over here. So these points that we have, I could have chosen to put them in a graph as well. So 10 and 10, that would have been where X is 10 and Y is 10. So that's right here. And then the other point is where X is 15 and Y is 1250. So 15 is the halfway point here, and 1250 is probably very close to this. This is not the best. This is 13, that's 1250. Okay, so like a quarter up, somewhere there. And this is not the best scale for this type of graph because it's not very accurate, but you could extend your line out and just have an idea. And you can see that here I'm not exactly halfway from 4 to 6, but I'm just about, and it gives you an idea that your initial value should be some number between 4 and 6. So we did end up getting 5, so that does make a lot of sense. You can also use a graph just to visualize what you're doing. Okay, so now that is the end of the video. So this has been word problems that follow a linear equation, and I will see you in the next one.